patterns of peat plants followed a pattern that we've all been taught in school, the idea that there are 2 gene copies for each gene. One goes into each gamete, at fertilization they come back together, and we are all diploid. And that's wonderful. That was very, very powerful. At the turn of the 20th century, all the fruit flies, Drosophila geneticists, were studying the anatomy of fruit flies, and all of their genetic traits followed that pattern, and they said, Eureka, we solved genetics problem. We now know that genes are inherited according to the laws of Mendel. Well, that's actually very logical because most of the DNA is on chromosomes, and that inheritance pattern is due to the chromosomes. However, we've applied this Mendelian logic to these diseases to the tune of hundreds of billions, if not trillions of dollars, and we still can't tell people why they have the disease and what we can do about it. So there may be something wrong with that idea as well. So what's interesting is that all the anatomical genes are in fact on the chromosomes. So all anatomical traits are Mendelian. So that was great for Drosophila geneticists. But now these diseases may or may not be anatomical. Just because you have a headache doesn't mean that there's something wrong with your head today that wasn't wrong or good yesterday. So that raises the question, well, what's missing? Well, life is not just about anatomy. Anatomy is, in fact, what you see in the mirror. When you go to medical school, the first thing you do is spend the whole year studying the anatomy, learning everything for the last half a millennia. But as I tell medical students, it would be great if your patient leaves the office in the same state as your cadaver. The anatomy would be fine. The only problem is the patient would be dead, and that probably wouldn't be good for your reputation. So the question is, why was the patient dead? Not the anatomy was wrong, something was missing. What was missing was energy. Newton said a half a millennia ago, mass doesn't move without energy. And you're the most animated thing in my environment. So therefore, being animated and being mass, energy must be critical. So why isn't half of medicine about energy? And yet, as far as I know, in most medical schools, you memorize the TCA cycle, go to sleep, and forget about it. Okay, so
I'll stop there, but he's very dry and complicated. But the take-home message is energy is important. And the way you make energy is from mitochondria. So if you just understand that the best way to improve your health is to improve your mitochondria, that's the whole idea of all of this. Now, the key is that mitochondria is in water. And when you dehydrate, you decrease the efficiency of this. You also change, because it's, you know how like when your phone, which is a semiconductor, if you leave it out like in the sun, it just doesn't work. It gets too hot, it just doesn't work. You have to cool it off to get it to work again. That's essentially how our bodies are. So temperature is very important because it has to do with how it affects water. Water is very important because it's how it affects our mitochondria. So let's start off with just a basic question, like how much water should you drink? You have to understand that that's different for each person. We live on a water planet. This is Apollo, I want to say 8. And basically, looking back at the Earth, you can see that it's pretty blue because it's mostly water. In fact, it's 71% of the Earth is water. So literally, we live on a water planet. That being said, interestingly, we're about 72% water. So there's a lot of parallel that we really need to think of the most voluminous thing in our bodies, which is water and how much water we get in. And interestingly, seawater has a little bit of salt, and frankly, we have a little bit of salt. So all of this sort of parallels that you need water, but you also need salt, and you need the right amount of salt. So one of the interesting things is we kind of got it wrong. Basically, this whole course is about flipping the script, because we went down a certain paradigm that, for example, sugar's good, salt is bad. We started that 50 years ago, and as you know, Dr. Phil might say, how's that going for you? And it's not going well. And it turns out we got the wrong white powder. So this is a good book if you're at all interested in salt, is I basically have to convince people to increase their salt, because most people are on a low salt diet. So there's only really kind of two tastes. There's sweet and there's savory. Salt is savory, sweet is sweet. So if you're on a low salt diet, you usually go to sweet. So And also you have to understand that once you start on a low-carb diet, you actually pee away a lot of water and salt, and you get low in salt. So we'll talk more about it, but I highly recommend all of you consider getting this book to listen to, just because it'll get you over your fear of salt. I probably take about 4 teaspoons of salt a day. That's just what I require, and the way I know that is I measure it. So we'll talk about it when you're ready. But I highly recommend learning about salt. So my goal is to get you to Goldilocks your water and salt intake. I'm not here as the high priest to say you should get this amount. I'm saying we should look at how much water. So we don't want too much. These are people who probably have congestive heart failure. And if you have a heart problem or a kidney problem, then you have to be very careful, because it's very easy to get overloaded with that. So if people have congestive heart failure, they're told to weigh themselves every day. If they gain weight pretty quickly, it's not because they're doing a lot of exercise and muscle, it's usually water. Then they have to take a water pill to get rid of it. So we don't want too much water. Babies especially should not get much water, because that's why it's you have to be a little careful if you're teaching a baby how to swim, like they kind of throw them in and stuff. It's very easy for them to get drinking too much water. They don't have that much body surface area, and they can get water intoxicated. And in fact, one of the things I always talk about, especially with young, thin females, well, any small person, that you have to understand that we sweat salt and water. And if you only take in water, it can lead to some disasters. And there's been some deaths in marathons from what's called low salt syndrome, which is called hyponatremia. So the way that goes is you're, for example, running a race as a female for, say, a cause. Like, God forbid, your sister passed away of cancer. You're in a cancer marathon that's going to raise money. You have all these sponsorships, and you're running, and you're just drinking water, but you're sweating salt and water. What happens is, as you keep drinking the water, your brain keeps its salt, your body loses its salt. Now you have dilute water in your body, and our body doesn't like that. It likes to equilibrate, so the water rushes to the brain, swells, and then people pass away. So it's interesting that you can get water intoxicated. So, and a lot of it, that's why you need, if you're exercising over an hour a day, especially if you're sweating, to add some salt to whatever you're doing. And I know those of us that do cycling for hours on a time, that we go to, you may not want to say this out loud, but we go to In-N-Out. They have these free salt packets. You can just do a 5-figure discount and walk out, and you can just open one of those, and like every hour or so you down one of those. So I think it's important to learn about water, learn about salt, and because there are consequences if you get too low in water, and that's called dehydration. So typically, this on your skin, med students learn that you'll see, and I'll do this in my office, where you pinch your skin, and if it stays up, that's called tenting. And that shows that you're not getting enough water. Most people, when they're dehydrated, will get a headache. So if we're with the Boy Scouts, and a kid get a headache, the number one thing we do is stop, give them water, give them salt, just to get them so they're better. Because what happens is you just get this massive headache, because your brain will keep its salt. If you lose salt in water, you'll start to get a headache first. You'll also sometimes get stomach ache. So a lot of these things, but in general, a lot of people just have poor performance, and they're thinking they have low energy or they have something else, when it turns out to be a hydration problem. And then the question is always, well, why are we dehydrated? We're not doing that much. We're just kind of hanging out. But, and this gets into our electromagnetism lecture, but you have to understand that where we're at right now, there's Wi-Fi going through there. There's a lot of electrical things in there. And frankly, all of these microcircuits act like low-dose microwave ovens. And we've all seen what happens to leftover meat when you put it in a microwave. Unless you wrap it in a wet paper towel, it dries out. So a lot of us are really drying out, and it is something that we don't really appreciate and we don't really understand. And this is where I find it when we get different side effects. Especially if you start on a low-carb lifestyle like we're kind of advocating, it's very, very common to get side effects, especially headaches, nausea, a bunch of stuff, because you're losing, low carb loses salt and water. So understand that when people go on a low carb diet, they go, oh wow, I lost all this weight. Well, most of it initially is water, and then it's salt. And a lot of people get what we call the keto flu. And the keto flu is no more than just dehydration. You know, you're going to have, first off, it is a withdrawal syndrome. So if you're used to a lot of sugar and you try to go on low sugar, it's like any other drug, you're going to go through withdrawals. So you're going to get nausea, you're going to have poor sleep, you're going to have irritability, you're going to have stomach problems, you're going to be super tired because you don't have the carbohydrates as energy, and you haven't really kicked into a ketosis, which is fat burning, so you kind of have nothing. So I encourage people when they're starting down a low carb lifestyle to make sure they hydrate up, salt up, and don't exercise. Just give yourself a chance to kick into fat burning. You'll be dizzy, you'll have brain fog, and these are all common things that are not uncommon to those of us in college that had hangovers, because it's very similar sort of things to a withdrawal syndrome from any of the neurogenic type of things. So sugar, alcohol, opiates, any of those things, they're very, very similar. And this gets, again, back to our blood-brain barrier. So our brains really only have, I mean, that's our most important thing. That's how we became the dominant species, was our brain. It wasn't our athletic ability or anything, it was our brain. And so our brain has a barrier to protect it, and it won't let the salt out. And there is the thought of osmosis and diffusion. So you actually, when you drink water, and if your brain is keeping its salt, but your body's low on salt, then the water will rush up into the brain and cause that swelling. And so if you're having headaches, especially if you're on a low carb lifestyle, the number one thing is bump up your water and bump up your salt. And so in the hospital, we do this all the time. You know, we make you, quote, NPO with saline IV. Well, that's basically fasting with salt water. And so you could do that. Gatorade, basically, I'm just very impressed with them in a sense. If you think about it, they make billions of dollars off of water, literally a pinch of salt and some